video we're going to look at chemical bonding, and in particular we're going to look at ionic bonding. So our learning intentions are to discuss compounds and the octet rule and to explore ionic bonding. So to begin the video we're going to explore a compound, and a definition of a compound is a substance that is made up of two or more different elements that are chemically combined. And these elements in a compound are usually combined by bonds, and there's two types of bonding that we can have. We can have ionic bonds and we can have covalent bonds. So we're going to look at these individually, and in this video we're going to focus on ionic bonding. But before looking at bonding, it's worthwhile discussing the octet rule, because the octet rule is what causes bonding to occur. So when bonding occurs, atoms tend to reach an electron configuration with 8 electrons in their outermost energy level. That is the octet rule. So if a compound is obeying the octet rule, it will have 8 electrons in its outermost shell when a bond is formed. Now, noble gases already obey the octet rule, and they are inert, so they form no compounds usually, and that's because they have 8 electrons in their outer shell already, so they don't need to bond with anything else in order to achieve a full octet. Some exceptions to the octet rule include transition metals, and elements near helium usually try to get 2 electrons in their outer shell because of period 1 in the periodic table. Now, we've mentioned that for the octet rule to be fulfilled, a compound must have 8 electrons in its outer shell. And this can be done using ionic bonding. And with ionic bonding, we form ions. And an ion is a charged atom or group of atoms. And ions usually form through losing or gaining electrons. And this will depend on what group the atom is in on the periodic table. So elements in group 1 tend to lose 1 electron and form an ion with a +1 charge, because if you lose an electron, you're losing a negative charge, so that makes the element itself positive. Elements in group 2 tend to lose 2 electrons and end up with a +2 charge. So elements in group 17, which some people call group 7 if you don't include the transition metals, they tend to gain 1 electron and have a -1 charge. So an ion that gains an electron will have a negative charge on it because it is gaining a negatively charged particle. Then electrons in group 16, which some people may refer to as group 6 if you're not counting the transition metal elements, they gain 2 electrons, and this gives them a -2 charge. Now, ions with a positive charge are called cations. So cations form when an atom loses electrons, and then negative ions are called anions. So anions form when you have an element gaining an electron. So finally, let's get to our definition of an ionic bond. An ionic bond is a force of attraction between oppositely charged ions in a compound. And ionic bonds are always formed by the complete transfer of electrons from one atom to the other. Now, a good example of this is sodium chloride, or NaCl, which is common table salt. So let's look at the formation of the ionic bond in sodium chloride. So when we're looking at the formation of an ionic bond, it's often easiest to look at the dot-cross method. So if we take a look here, we can see that we have a sodium atom, and the sodium atom has an electronic configuration of 281 from Bohr. That then combines with a chlorine atom, which has an electronic configuration of 287. So as we can clearly see here, the sodium will want to lose this 1 electron to give it a full octet, and this chlorine will want to gain an electron to give its full octet. So that's why sodium and chlorine react together to produce a sodium ion that we have here. So this is a positive ion, so it has lost an electron. and is called a cation. And here we have our negative ion, which is the anion, and that's negatively charged because it's gained this blue electron from the sodium. And it's important that to obtain full marks, you must ensure to have the Bohr electronic configuration underneath your ionic bond formation. So let's do another example where we have to show the formation of calcium chloride using a suitable diagram. So again, we'll use the dot cross method. And as we can see here, we have a calcium atom, and it has 2 electrons in its outer shell with the 2-8-2 Bohr configuration, and it's been reacted with chlorine. So we can see that chlorine has 7 electrons in its outer shell with a Bohr electronic configuration 2-8-7. Now, we need 2 atoms of chlorine, and the reason we need 2 atoms of chlorine is we have 2 electrons that we want to get rid of in the calcium, but each chlorine can only take 1, so we need 2 chlorine atoms in order for this reaction to work. And what this will produce is, it will produce a calcium ion where it has a 2+ charge because the calcium has lost 2 electrons. And each of the chlorines will have a negative charge on it because they will gain 1 electron each from the calcium to obtain a full outer shell of 2-8-8, forming chloride ions. So to finish up, let's just look at the 3D crystal structure of sodium chloride. So this is our 3D structure here, and it is called a crystal lattice. And what we can see is we can see a repeating unit in the lattice called a unit cell. And basically what we have here is we have our sodiums and our chlorines alternating. So sodium, chlorine, sodium, chlorine, sodium, chlorine. So we have a repeating unit there of sodium and chlorine, and that repeating unit is called a unit cell. So that's it for this video. Have a read over the learning intentions to make sure